This video will give you some tips for solving the problems 79 through 86 on page N of 1135. First of all, let's look at number 79. We have a runner runs a race, and we know it's 1,500 meters, and we know that it's 4 minutes, and we have his mass. We're supposed to find kinetic energy. So remember, the formula says we need to know the mass and the velocity, and then we can use 1/2 mv squared to equal the kinetic energy. Do we know the mass? Yes. Do we know the velocity? You say, well, no, I don't see the velocity in number 79, but we do know the meters, so we can take that, convert the minutes into seconds, right? And then divide meters divided by seconds. Ta-da! We'll have meters per second. And then we can use the formula. All right, so there's your tip on that one. The last two here, 81 and 82, I just want to show you, very simple. This formula for potential energy is mass times acceleration due to gravity, which you know by now is 9.81, and then the height in meters. So both 81 and 82, they give us the mass and they give us the height above the ground in both cases. So all we got to do is plug in the 9.81, multiply the height and the mass, and you have your answer. Make sure you round your answers to, it looks like, 3 significant figures. And then, of course, since it is energy, it'll be in joules, right? Okay, let's talk about number 80. This is probably the trickiest one in this little section. We have a plane landing at 140 kilometers per hour. We want to find the kinetic energy, and we have the mass. So we have 140 kilometers per hour, but that's not the units that we need to have it in. So we have to do a conversion, and we're going to cancel the hours against hours, minutes against minutes, and then kilometers against kilometers, and then the answer will come out in meters per second, which is what we want. So do it on your calculator and just confirm that you get this same answer, okay? 38.89 meters per second. Now that's the velocity. So that is what you'll plug in here for velocity. And of course the mass was given, that was 1,000. When you get your final answer, you are going to have to move the decimal 5 places, and then you'll have significant figures, 3 significant figures, and we call this scientific notation, as you know. And again, the answer comes out in joules. All right, so anyways, you finished that one. Do the work to get number 80 correct. And now let's give you a heads up here on 84, 85, and 86. On 84, it says, what is the kinetic energy of an automobile weighing 1,600 kilograms? Okay, that's good, that's what we want. And we first have 25 kilometers per hour. Okay, that's not the units that we need it in, right? We need the velocity in meters per second. So you're going to have to convert 25 kilometers per hour into meters per second. And then you can use this familiar formula to solve for the kinetic energy. Now they want you to do it again. Convert 50 kilometers per hour into meters per second. Use the same mass. Solve for the kinetic energy. And then I want you to compare. Right off the top of the bat here, you might think that these two answers are going to be just double. If this is 50 kilometers and this is 25, you'd think, oh, this answer is going to be double this. But I want you, after you do the math, to compare the two and find out. I'll give you a little hint. It's not double, okay? Something else. All right, let's look at number 85. What is the kinetic energy of a 1,000 kilogram object? Okay, so that's easy. As it strikes the ground after falling for 2.25 seconds from a 10-story building. All right, so once again, they give us a piece of information that we do not need to know. We don't know. We don't care. It doesn't matter that it's a 10-story building. The part of this that is important is the mass. We can take the time, and then remember this formula, final velocity equals gravity times time. And of course, gravity is 9.81. So we can take the time times 9.81, and we have the final velocity. That's what we're going to use to plug in to velocity squared. All right, I think we've done enough on 85 that you should be able to solve that one. Let's talk about number 86 now. 86, it says a 1,000 kilogram car strikes a tree with the same kinetic energy as in problem 85 above. At what speed was the car traveling? All right, first of all, stop. Make sure you have solved 85 because you need the answer from 85. I'm waiting. Come on, stop the video, solve 85 and get an answer, and then we can move on. All right, I'm trusting you. I hope you have the answer. Here we go. Now 86. We know the mass. We are going to use this formula, 1/2mv squared. That's a familiar formula. So we know the 1/2. We plug in the mass, and we're going to solve. This is what we're solving for, is the velocity. It says, what is the velocity in meters per second? Well, what is the kinetic energy? Because that's the other thing that we need to know. Well, that is the answer that you got from problem 85. And that should be this number right here, okay? So if you plug that in, and now, so let's say we have this 2.44 times 10 to the 5th, and we divide by 500, now you'll have velocity squared equals the answer to that. All right, how do we undo squared? We do the square root. So take the answer that you got there, do the square root of that answer, and ta-da, you have the speed in meters per second. And I'm pretty sure we're going to have 3 significant figures again for this one. Then they want you to take that answer and do it in kilometers per hour. And actually that's pretty easy because you're just going to do a conversion from meters to kilometers and from seconds to minutes, minutes to hours. So I'm going to let you finish that one. That one should be fairly easy. And that takes us up through problem 86.